UV Vis spectroscopy is a common analytical method used in many fields of science. It utilizes the phenomenon of absorption of light rays in the range of 180 to 720 nanometers to detect the qualitative and quantitative aspects of chemical species, such as concentration. Today, we'll be looking more closely at a simple UV Vis spectrometer to understand how it functions. We'll focus on two types of spectrometers, single and dual channel. Single channels can only detect a single sample per trial. This means that after measuring the sample, the cell needs to be replaced with the reference. The blank is subtracted manually afterwards. Dual channel designs include cells for both the sample and reference. Double beam in space utilizes a beam splitter to hit the sample and reference, then detects simultaneously. Double beam in time uses a chopper to block off the beam, so it only hits one cell at a time, so it can be detected using the same photodetector. All spectrometers also need a light source. The source will depend on the range of wavelengths that is needed. For example, a deuterium lamp is used for UV because it produces light beams with wavelengths ranging from 160 to 370 nanometers. Light is produced by the electrical excitation of deuterium. Many spectrometers also use wavelength isolators, which allow one wavelength of light to be analyzed at a time. Different wavelength isolators include filters, prisms, and diffraction grating. Wavelength isolators are used in monochromators, which focus the beam directly and allow the wavelength isolator to be in one component of the spectrometer. Monochromators consist of an entrance slit, a collimator to realign rays in a parallel direction, the wavelength isolator itself, a refocusing element, and an exit slit. An ideal monochromator should produce a beam of light that includes only one wavelength. Any analytical instrument requires a detector to pick up the signal. Over time, detectors have improved in sensitivity. Detectors are similar in that they convert incident photons into electrical currents. Compared to the earlier vacuum phototube, the photomultiplier tube can detect very low amounts of photons and amplify the response through the use of many diodes. Newer instruments utilize diode arrays, which are able to detect many wavelengths simultaneously and separate electronically after detection. Thank you for watching.